All right, so more into these rules. So again, there are three basic probability rules. The first one is it has to be a number between 0 and 1. We talked about that last section, right? So it's going to be a decimal between 0 and 1 or a fraction. Okay. Next, all possible outcomes together must have probabilities that add up to 1. So when we think about these probabilities, the number 1 actually means 100%. So if you think about it in the past chapters, we always needed 100% of the data represented. Well, same thing here in our probability models. Have to have 100% of the data or probability of 1 together. And the probability that an event does not occur is 1 minus the probability that the event does occur. This is called the complement rule. So for the complement rule, here is the notation, right? So the probability of AC. So AC is the complement of event A. Again, the event that A does not happen. So that's just 1 minus the probability of A. And there we go. So sometimes it's easier, instead of to find, say your probability of A involves a couple different probabilities having to be added together. Instead of adding them together, it might be easier to, take 1 minus everything else, okay? And vice versa. Okie doke. Sorry about that. Okay, so let me get out of here real fast. Exit that, present, and we'll go to the next slide. Okay, so example 2, can you avoid the blue M&Ms? Suppose you tear open the corner of a bag of M&Ms, milk chocolate candies, pour one candy in your hand and observe the color. According to Mars Incorporated, the maker of M&Ms, the probability model is this. So here's your color distribution, and then here's your probabilities that go with each color. Explain why this is a valid probability model. So first, look at the 6 probabilities. Each probability is a number between 0 and 1. Each probability is a number between 0 and 1. Second thing, we need to add up these probabilities. So 0.24 plus 0.20 plus 0.16 plus 0.14 plus 0.13 plus 0.13. When I do that very quickly, I assume I'm going to get 1, right? Why would they set up this problem like that? 0.24 plus 0.2 plus 0.24 plus 0.2 plus 0.16 plus 0.14 plus 0.13 plus 0.13. Boom, I do get 1. So the 6 individual probabilities do add up to 1. Okay. Problem B says, find the probability that you don't get a blue M&M. So let's say that B means you get a blue. So then B complement means not blue. So I want to find the probability of B complement. Well, you could add up, orange plus green plus yellow plus red. But why do that? You can also just take 1 minus the probability of getting a blue. And that probability of getting a blue is right here, 0.24. So there are 2 ways to do this. You can add up all the other probabilities, which is fine, or you can just take 1 minus the probability you don't want. And 1 minus 0.24 is 0.76. All right, objective 2 is done. Objective 3 is coming up.